is that as soon as all of your assertions pass and you get no red warning output on the screen, you know my code is correct, at least so far as my tests are concerned. So if you've ever wondered what your TF might be doing behind the scenes, he or she is probably running the equivalent of unit tests, because he or she hopefully is not manually testing and writing programs manually to test all the submissions of 15 plus students. Rather, we write things that are much more automated than that. So with unit tests, you yourself can do this so that, frankly, the next time you change your code at like 1 a.m. and you hit save and then you submit it thinking, oh, that's all fine, right? You actually have a sanity check that you yourself wrote that can say yay or nay, you just broke all of your code. And better yet, now that you're working with a partner, right, you have this contract right now based on trust that he or she is not going to go and screw over your entire project by introducing some bug. This way, you can actually validate that his or her code is correct, or at least correct so far as the tests are concerned. So there's this other buzzword in this world of testing called regression test or regression testing. What is a regression in the context of software development? Yeah?
Something that worked before but no longer works.
Perfect. Something that worked before but no longer works. Like you have regressed in the literal sense to some earlier, poorer form of the code. So a regression test is typically a test like this one, test add, that you yourself would write when you realize, damn, we just introduced a bug. Let me make sure I never again make that same mistake. So you introduce a test to test the input and output of some method so that if you do ever break it again, you can detect it. And you can fix it before you actually push your code out to some production server or some actual device. So unit testing, and I honestly am quite happy to admit, I didn't do this for years because it always seemed like bureaucratic headache and nonsense and all of this. But the reality is even I am now in the habit of writing tests for my code as I write my actual code in parallel. There's a mental model that some people have where test first, test-driven development, where you actually write the tests first for all of the methods you promise to implement, for instance, in your design documents, and then you write the code, because then you have instantaneous answers as to whether or not your code is correct. And again, an astute person will realize there's this infinite recursion potential where what if your tests aren't correct? So generally, you don't write tests for the tests, but you write the tests in a sufficiently succinct way that there really is little, if any, room for error in your own tests. And you typically use a framework, like we'll introduce after the break, that you should hopefully be able to assume, since it was written by Apple, it's used by millions of people, so at least it's gotten lots of eyes on it, itself is correct. And probably the weak link is going to be your code, not the rest of the world. So why don't we go ahead and take a 5-minute break here, and then we'll start actually writing some of these on the fly. So before we dive into some actual test writing, a quick review question that I waved my hand at and then forgot to come back to before. So this was the SQLite example. This was the viewcontroller.m file. Why did I have my property here declared in the M file as opposed to the header file, which is where we started putting properties a couple weeks back? Yeah?
You don't want anyone else to know about it.
Yeah, so if you want some notion of privacy whereby you, the viewController class, are really the only one who cares about this property, and you've declared it so that you get the dot notation and so that you get the automatically synthesized getter and setter, but you really have no need to advertise it to anyone else who actually interfaces with this code, even though, admittedly, there is no one else in question in this small example. You can create, effectively, a private property by simply declaring it inside of this thing called a class extension. What's a class extension? Well, again, it's just the use of a category that has no name. What's a category? It's kind of a cyclical story here. What does a category allow you to do in Objective-C? We've not really had to use these ourselves. It allows you to extend a class, an existing class. So if you want to add functionality to the NSString class that Apple didn't think to implement, you can do that by redeclaring the NSString interface, but having your own category by, in parentheses, having a name like foo, which represents your addition to that. Those of you comfortable with JavaScript might know that you can do the same in JavaScript by extending a object's prototype, the .prototype property. Yeah?
In this example, it doesn't really make a difference, but if we had multiple view controllers and we make a database like that, will we be able to do database queries from other view controllers?
Good question. So if you have multiple view controllers, maybe like in Project 2, Will you be able to have them talk to one another? So short answer is it depends. And at least in the context of project 2, which I'll presumptuously assume is of most interest, you have flip side and main view controller. And those two don't really talk to one another directly. Rather, they talk to one another by way of delegation. So recall that the flip side controller gets in a pointer called the delegate to the main side controller. So if your main side controller has these properties declared and the flip side controller has a pointer there too, to a main view controller object, you can certainly invoke properties in that way. So in short, it depends on who you want talking to whom. And frankly, for the limited scope of the project, it's not a bad thing to practice what we originally preached, which is putting properties in header files and not getting into this additional degree of sophistication. But for those of you who really do kind of want to think about like what are every possible design decisions I can make and maybe should make, realize that this is one of the options. All right. All right. So think back to this example here. This is from a couple weeks ago. And this was one of the very first apps we wrote that did a little something more interesting than just printing to NSLog. And it was an ATM whereby I can punch in some numbers and pretend to make various deposits. And recall this was our first discussion of interface builder where we dragged and dropped the blue lines to create IB outlets and IB action linkages between code and the UI. So what kinds of things might I want to test in this application? What kinds of things might go wrong? You submit this as your homework assignment. What might your TF say, doesn't work right?
Maybe you tagged it wrongly.
OK, so maybe you tagged it wrong. So pressing 9 actually displays 3 or something like that. That's reasonable. Right? Does pressing 9 display 9? That's a reasonable question and reasonable something you'd want to test. What else? Yeah?
If you deposit a lot, like more money, like a ton of money in the bank account, whether it still has that balance that you would expect.
OK, good. So if you deposit $50 plus $100, do you actually have 150 in the balance at the bottom of the screen? So that's a reasonable question to ask. So does your deposit method work? Right, what else might go wrong? Yeah?
When you say that you deposit $150 on the screen, does it actually deposit $150?
OK, good. So once you start doing multiple key presses like 1, 5, 0, are you actually doing that multiplying by 10 thing we talked about, the sort of grade school math to actually change what's actually in the label up top so that you actually do deposit 150? So in short, something could go wrong in most any one of the methods that we implemented in this program. And now what were those methods? Well, let's just take a quick tour back. Here's the app delegate, which is a good place to start the story. And there's really nothing of interest here. This is all boilerplate code that I simply cleaned up with some comments. So if I then turn my attention to init with nib name and the view controller in the .m file, well, let's see what's actually in here. I didn't actually override that because it wasn't necessary because all the initialization comes from the nib itself. So what methods did I have? Well, I had a method called clear, which is what gets invoked when the user hits the clear button, assuming my IB outlets were wired, my IB actions were wired correctly. Deposit, which is called when I push deposit. Digit, which is called when I press any one of the 10 digits. Show, which was a little helper method that I wrote. Should auto rotate to interface orientation, which gets called when I rotate the device. View did load, and so forth. So what are the best candidates for testing here? Probably Apple's should auto rotate method is probably correct, assuming if I'm just returning true or false. But really the interesting question is, do the methods that I wrote that other people are going to call correct? Right? It's because if those things are incorrect, maybe your problems are in those methods themselves, or maybe in some of your helper routines. So a very common approach is to have unit tests specifically for your public API. That is methods that something else is going to call. And in the case here where I actually have a little helper method called show, I could write a test for that and make sure it does actually show what I expect. But really at the end of the day, especially for large software projects with multiple people, you care about testing especially your public-facing API, because that, after all, is what's going to break first when other people start using your code. So how do we go about testing this stuff? And actually, what else is there? Well, recall that there's also this model. So also related to Project 2, where you're tasked with creating models for high scores and for your gameplay. Well, here's a very simple model whereby I represented the notion of a bank account with really something super simple, a property called balance that's just a long int, an unsigned long int. And it was implemented only with one helper method called init, which initializes the balance to 0. So the upside is very easy to test that. Make sure that the balance is indeed 0 when I create this thing. Downside is the whole account doesn't really do much, but that's fine. Less to test. All right, so how do we go about creating some unit tests? Well, Couple of ways. When you first create an Xcode project, suppose it's a utility application, and I click Next, besides typing in something like Hangman at the top, you can check off at the bottom, use automatic reference counting, which you absolutely should per the spec. And you can also check Include Unit Test, which is going to give me some boilerplate code for actually bootstrapping this process. If you and your partner did not do that, that's fine. You can still retroactively add unit tests to your code. Realize that the quick tutorial for doing so is at this URL here, which is on today's slide. So you can read the various documentation there. If I go ahead and click Next, in the case of Hangman here, click Create, what I'll get on the left-hand side, as you yourselves might have already noticed, is not just the typical boilerplate, but you also get this directory here called Hangman